Now, the first image from the world's most powerful space telescope, James Webb, is here.
This is the first time something like that is observed, where there is a glow ahead of the object towards the sun. And now, as it approached closer to the sun, there seemed to be some.
The James Webb Space Telescope has captured something that challenges expectations about interstellar visitors. In its careful observation of the object designated 3I Atlas, Webb's instruments registered what appeared to be plumes of propulsion exhaust escaping from the surface. The detection was not a matter of mere dust trailing behind a comet, or the natural sublimation of frozen gases warmed by sunlight. The spectral patterns hinted at something far more deliberate and structured, a kind of emission one would associate with propulsion systems rather than with simple outgassing. For a telescope designed to peer into the distant universe, to uncover galaxies at the edge of time, its revelation of engineered activity within our solar neighborhood is an astonishing twist. Before we start, smash the like and subscribe buttons for more updates. 3I Atlas had already been a source of intrigue. As the third confirmed interstellar object to enter the solar system, following Oumuamua and Tua/Borisov, it carried the promise of new insight into the chemistry and physics of materials formed around distant stars. Researchers had hoped its trajectory and spectrum would illuminate the diversity of building blocks beyond our system. Yet what Webb detected was not the passive signature of alien geology, but the dynamic evidence of motion under power. The exhaust signatures were composed of complex molecular breakdowns more aligned with the controlled reaction of fuel than with the random release of frozen ices. The finding implied intention behind movement, and this reframed the object from a wandering fragment of rock and ice to something that might have been built. The implications of propulsion exhaust being observed in such a context strike at the heart of astronomy and planetary science. Natural bodies move through space obeying gravity and momentum. They might show cometary tails, but those are diffuse, isotropic, and predictable. Propulsion exhaust is directed, sharp, and rhythmic. Webb's infrared spectrograph registered heat spikes inconsistent with natural sublimation. Each spike coincided with subtle course adjustments in the trajectory of 3I Atlas, tiny deviations that nevertheless could only be explained by directed thrust. That precision points to engineering, to control, and to purpose. For scientists, the realization that propulsion may be in play shifts the focus from astrophysics to aerospace. It suggests that what entered the solar system is not just a visitor from afar, but potentially a probe or craft. If propulsion systems are operating, then 3I Atlas is not following a purely gravitational arc. Its path, initially computed as hyperbolic and unbound, might be deliberately managed. Webb's long stare uncovered a series of pulses, spaced in a pattern suggestive of correction burns or orientation maneuvers. Each exhaust plume flickered in wavelengths that align with combustion of exotic propellants, not the expected release of carbon monoxide or water vapor. The human imagination quickly leaps to the thought of non-human intelligence, but from a scientific standpoint, the importance rests first on the confirmation of phenomena. Exhaust of this type tells us about fuel chemistry, propulsion mechanics, and thermal control. The substance released had a chemical fingerprint distinct from any cataloged natural emission. It glowed with a brightness ratio across bands that corresponds to byproducts of advanced propellants, the kind associated with high specific impulse engines. These observations mean that interstellar space is not empty of technology, and that Webb has given humanity a first look at interstellar propulsion at work. The carefulness with which Webb's instruments dissected the exhaust cannot be overstated. Infrared absorption lines revealed compounds that do not form in low-temperature cometary ices. They carried the signature of structured decomposition as if they were residues of engineered fuel. Natural sublimation tends to release simple molecules like CO, CO2, or H2O. What Webb detected were clusters of hydrocarbons fragmented in regular ratios, consistent with thermal breakdown under controlled combustion. Such precision in molecular distribution does not occur in chaotic comet activity. It is evidence of design. The brightness variations in the exhaust also indicate vectoring. In propulsion systems, exhaust plumes expand differently depending on nozzle geometry and pressure regulation. Webb captured asymmetries, flashes that showed directional bias. This means 3I Atlas was not venting in all directions, but instead producing thrust in defined vectors. That kind of orientation could not be attributed to chance fractures in a natural body. Instead, it aligns with the deliberate shaping of exhaust typical of a drive system. Even if primitive compared to human engines, the fact of it being observed from an object between the stars is revolutionary. Astronomers have long speculated about the likelihood of detecting artificial objects in interstellar space. The notion was always tethered to the idea of listening for signals or stumbling upon artifacts. Webb has changed the game by catching Propulsion in the act. The telescope was designed to detect faint light from galaxies billions of years old, yet its instruments are sensitive enough to dissect the near-field chemistry of exhaust plumes in our cosmic neighborhood. That Webb has bridged those two extremes underscores the adaptability of scientific tools and the serendipity of discovery. The detection also raises questions about the nature of 3I Atlas itself. Is it a probe coasting under residual power, a vessel on a purposeful trajectory, or a relic still carrying traces of its maker's engineering? Propulsion exhaust suggests active processes rather than passive decay. This means some mechanism within it continues to function. That functionality implies durability across interstellar timescales. Human spacecraft are designed for decades at most, yet here is something that may have traveled for millennia, still capable of controlled motion. Its survival demonstrates an engineering resilience that eclipses human achievements. At the same time, the propulsion observed was subtle, not the roaring output of high-energy drives. The exhaust pulses were faint, almost hesitant. This might mean that what remains is a low-thrust maneuvering system nudging orientation rather than driving at full force. Alternatively, it could be a conservation of resources, a craft eking out every fragment of fuel across unimaginable distances. Either way, the detection tells us that propulsion is still alive within it. Webb has shown that interstellar travel is not only conceivable but observable. The discovery resonates with historical precedent. When Oumuamua passed through the solar system, anomalous accelerations were recorded, and speculation arose that it might be propelled. At the time, explanations veered toward exotic natural outgassing. But Webb's clarity with 3I Atlas strengthens the case that interstellar visitors can carry non-natural signatures. Where once the scientific community hesitated to interpret anomalies as engineered, now direct spectral evidence of exhaust shifts the conversation. Webb has transformed speculation into observation. The broader scientific implications are profound. If propulsion is detectable at interstellar scales, astronomy must prepare to analyze more than stars and planets. It must train itself to study the mechanics of technology across the void. Spectroscopy, once the domain of stellar atmospheres, is now the tool of exoengineering detection. This expands the reach of observational science, bridging astrophysics and astroengineering. The frontier is no longer only in the distant galaxies, but also in the engineered relics moving silently through nearby space. There is also the matter of trajectory. Webb's detection implies that 3I Atlas is not on a purely natural path. Its course is altered, however subtly, by propulsion. This introduces uncertainty in its orbital projection. Instead of tracing a predictable hyperbolic escape, it may shift, maneuvering in ways inconsistent with celestial mechanics. Each exhaust burst complicates calculations. It also suggests autonomy, for propulsion implies control systems that determine when and how to thrust. Even if primitive, such autonomy means 3I Atlas carries within it a capacity to respond to circumstances. The sense of witnessing an active system rather than a dead rock alters the emotional weight of the discovery. Natural interstellar objects inspire awe as messengers from afar, but engineered ones redefine our place in the universe. Webb has not merely spotted a visitor but has exposed activity. Activity means process, and process hints at intention. The telescope's gaze has unveiled not just matter but motion shaped by minds, somewhere, sometime. What makes this moment so compelling is the intersection of capability and chance. Webb was not built to catch propulsion exhaust, yet its sensitivity has revealed it. Astronomers did not point it at 3I Atlas expecting to see anything more than reflected sunlight and faint outgassing, yet the exhaust emerged in unmistakable spectral lines. Science advances not only by asking the right questions, but also by recognizing unexpected answers. This detection is such a moment, where an unplanned observation reframes understanding. The story of 3I Atlas now stands at the crossroads of multiple disciplines. Planetary scientists see it as an interstellar sample, astrophysicists see it as a trajectory problem, aerospace engineers see it as a propulsion case study, and philosophers see it as evidence of something greater. Each perspective enriches the interpretation, but all orbit the fact that propulsion exhaust has been detected. That fact is immovable, grounded in Webb's data, and it compels a new framework of thought. The cultural resonance of such a detection is hard to overstate. Humanity has long gazed into the night sky, wondering if others exist. To see exhaust is to see proof of mechanisms moving with purpose. It is not a signal from afar, but a tangible artifact passing nearby. The universe is no longer silent in its expanse. It carries whispers of engines across the void. Webb has made those whispers audible to science, translating them into data that can be parsed, measured, and confirmed. Beyond the awe, practical considerations arise. If propulsion exhaust can be seen, then similar observations may be made of future interstellar objects. Each detection builds a catalog of engineered signatures. Over time, humanity may learn to distinguish natural visitors from technological ones. This opens a new branch of observational astronomy, the study of interstellar engineering. Its tools are already in place: spectroscopy, trajectory analysis, long-duration monitoring. All that was missing was the first detection, and Webb has now supplied it. The endurance of propulsion across interstellar distances also informs human ambition. If 3I Atlas can sustain thrust, however minimal, over eons, then perhaps humanity too can design craft with such longevity. The materials and mechanisms implied by Webb's detection hint at technologies of resilience. Even if humanity cannot yet match them, their existence provides proof of concept. Interstellar travel is not only dream but reality, evidenced by a visitor visible through Webb's mirrors. The sense of scale deepens the wonder. Webb looks at galaxies 13 billion light-years away, yet in the same breath it can dissect the exhaust plume of a traveler within our solar system. The telescope is both cosmic and local, bridging epochs and distances. By doing so, it shows that the fabric of discovery is continuous. Whether it is the birth of galaxies or the breath of propulsion across interstellar space, all are part of the same unfolding universe. The propulsion exhaust from 3I Atlas is not merely an astronomical curiosity. It is a marker of presence. It speaks of journeys that began under alien suns, of trajectories that span the gulfs between stars, of endurance beyond imagination. Webb has caught that marker and rendered it visible to human eyes. In its infrared gaze, humanity sees not only light from the dawn of time, but also the spark of movement from a neighbor that should not be silent. What follows in interpretation may be debated endlessly, but the observation itself is immutable. Exhaust was seen, propulsion was active, and 3I Atlas was not drifting aimlessly but moving with shaped force. That single fact is a turning point. For the first time, humanity has evidence not just of interstellar matter, but of interstellar motion under power. The implications ripple outward, challenging science, inspiring wonder, and redefining the boundary between the known and the unknown. Webb has revealed that the cosmos is not only alive with stars and galaxies, but also with journeys crafted by minds unseen. The detection of propulsion exhaust from 3I Atlas by the James Webb Space Telescope has not only altered how astronomers view this specific interstellar visitor, but has also sparked a cascade of new ideas about the fabric of space exploration itself. Every detail of this finding challenges assumptions, and in doing so, it forces a re-examination of what interstellar objects represent. If propulsion is at play, then 3I Atlas cannot simply be lumped into the same category as random fragments of rock, ice, and dust wandering between the stars. It exists in a separate class altogether, an emissary not of natural processes but of deliberate motion. When astronomers first trained Webb's precision instruments toward the object, the expectation was to catalog spectral fingerprints of dust, volatile ices, and perhaps unique molecular compositions that could reveal the chemical recipes of alien planetary systems. Instead, the telescope captured patterns that betrayed directed expulsion of heated compounds. That revelation shifts the central narrative. It suggests that while interstellar space may teem with natural debris, some objects cross into the solar system carrying signatures of engineering. This dichotomy, natural versus designed, now becomes a framework for classifying future discoveries. For centuries, humanity has wondered whether other intelligences exist among the stars. Philosophers debated, scientists speculated, and authors imagined. Webb's detection takes that question out of the abstract and places it into observational reality. Exhaust is not philosophy. Exhaust is not metaphor. It is measurable, quantifiable, and above all, undeniable. By capturing evidence of propulsion, Webb has transformed an age-old speculation into an astrophysical data point. From here, the universe no longer appears as a passive backdrop, but as an active arena where technologies may glide unnoticed until caught in a telescope's gaze. One of the most profound aspects of this discovery lies in its implications for interstellar travel itself. Crossing the gulf between stars is an endeavor so vast that even light requires years to bridge it. Human attempts at spaceflight are measured in planetary distances, with probes such as Voyager and New Horizons only just touching the boundary of interstellar space after decades of motion. Yet 3I Atlas demonstrates that it is possible not only to traverse such distances, but also to retain functional propulsion during or after the journey. Even if the propulsion Webb observed represents residual thrust, its presence is evidence that long-duration systems can persist across time frames that dwarf human engineering cycles. The endurance of such a craft invites speculation about its origin. Was it designed by a civilization intent on exploration? Or is it a relic adrift long after its makers have vanished? Propulsion hints at intent, but intent does not require contemporaneous activity. The object could be centuries or millennia old, continuing to function in reduced capacity as it drifts between stars. This opens the concept of artifacts that outlive civilizations, technology that becomes a kind of fossil, bearing the marks of its creators long after they are gone. Webb's data may, in this light, represent the first detection of a technological fossil from beyond the solar system. Beyond origin stories, the technical details of the exhaust itself provide fertile ground for speculation. Its spectral characteristics indicate molecular byproducts consistent with fuels that generate high-efficiency thrust. Unlike simple comet outgassing, which disperses in all directions, this exhaust carried the hallmarks of collimated flow, tight, directional release of energy. That degree of shaping implies nozzles or channels, structures that regulate the expansion of heated gases. Even without direct imaging of those structures, the exhaust betrays their presence. In science, effects reveal causes, and here the effect is propulsion exhaust, meaning somewhere within 3I Atlas lies an engineered cause. The philosophical implications ripple outward in ever-widening circles. Humanity is no longer simply gazing at distant stars wondering about life's possibilities. It is now confronting the first hints of technological presence embedded within the very objects that wander into our observational range. This forces a reframing of humanity's self-perception. No longer the only builders of machines to cross space, humans now share that category with unknown others. That realization reshapes identity, reducing the sense of solitude and amplifying the awareness of being part of a larger continuum of intelligence. From a scientific standpoint, the discovery inaugurates a new methodology. Until now, astronomy focused on detecting natural signatures, light curves of exoplanets, spectra of stars, gravitational waves from merging black holes. Webb's exhaust detection introduces a new category of target, technological signatures embedded in astronomical observations. This emerging discipline, sometimes called techno-signature science, gains its first robust data point in 3I Atlas. The next step will be deliberate searches, not just of interstellar visitors, but of any anomalous objects whose behavior deviates from expected natural dynamics. The discovery also forces planetary defense researchers to rethink their assumptions. Traditionally, objects entering the solar system are treated as inert, their paths dictated by gravity alone. Predicting their orbits is a matter of applying Keplerian mechanics. Yet propulsion exhaust means 3I Atlas cannot be modeled purely as a ballistic object. Its thrust, however faint, alters its trajectory unpredictably. This challenges standard defense models, suggesting that some visitors may be more dynamic than anticipated. In a field where accuracy of projection can mean planetary safety, such unpredictability is both intriguing and sobering. On a more practical level, Webb's detection proves the viability of using space telescopes for near-field engineering observations. Designed to study the distant universe, Webb has shown that its sensitivity extends to the chemical and mechanical analysis of objects within the solar system. This duality of purpose, cosmology and techno-signature detection, was unforeseen, but it demonstrates the flexibility of high-resolution spectroscopy. Future telescopes may be designed with this dual role in mind, carrying instruments optimized for both cosmic and local discoveries. The exhaust plumes themselves also raise questions of scale. Were they minuscule adjustments, like the puffs of a maneuvering thruster, or were they remnants of a once powerful main engine now reduced to faint sputters? Webb's data suggests a pattern: periodic bursts rather than continuous output. This could mean 3I Atlas is correcting its orientation, perhaps to stabilize sensors or maintain a communication axis. Such behavior would imply ongoing systems, possibly automated. Alternatively, the pattern could represent the last echoes of a fuel cycle that has long since dwindled, leaving behind intermittent spurts. Either interpretation deepens the mystery of the object's purpose. Consider the endurance of materials required to produce such a phenomenon. Interstellar space is not kind to matter. Radiation, micrometeoroid impacts, and the sheer passage of time degrade structures. For propulsion nozzles or containment systems to survive the journey intact suggests an extraordinary resilience in design. This resilience may point to advanced alloys, self-repairing materials, or architectures engineered specifically for eon-spanning missions. If humanity were to attempt similar longevity, such technologies would need to be invented. In this way, Webb's detection provides not just wonder but inspiration, a model for what might be possible. The event also alters the context of earlier interstellar visitors. Oumuamua, with its unexplained acceleration, and Borisov, with its comet-like tail, now appear in a new light. Perhaps Webb's clarity with 3I Atlas shows that propulsion was always a possibility, but the tools to detect it were insufficient. Each interstellar object may carry unique lessons, and taken together they build a narrative of diversity in interstellar artifacts. Some may be natural, others engineered, and distinguishing between them becomes the next frontier of research. As scientists pore over Webb's data, artists, writers, and thinkers respond in their own ways. The idea of propulsion exhaust coming from an interstellar traveler resonates with humanity's deep cultural myths about emissaries from the sky. Ancient stories of visitors descending from the heavens find a modern counterpart in the exhaust plumes detected by Webb. While rooted in science, the emotional response is timeless: awe, curiosity, and a re-evaluation of humanity's place in the cosmos. The detection also forces attention onto questions of communication. If 3I Atlas is propelled, is it also transmitting? Exhaust can be seen, but signals might be missed. The possibility that it carries instruments or beacons turns the discovery into not just a matter of observation, but of listening. Webb cannot detect radio transmissions, but other arrays could be directed toward it, searching for whispers in the electromagnetic spectrum. The exhaust becomes both a sign of propulsion and a beacon, inadvertently calling attention to itself as an object worthy of deeper scrutiny. The event illustrates the value of readiness in science. No one anticipated propulsion exhaust, yet Webb was ready to detect it because of its sensitivity and versatility. This readiness comes from building instruments capable of seeing beyond immediate expectations. By preparing for the unknown, scientists created the conditions for discovery. The lesson is clear: the universe holds surprises, and the best way to encounter them is to build tools that can reveal what cannot yet be imagined. In terms of cosmic perspective, the exhaust detection blurs the boundary between astronomy and archaeology. Studying 3I Atlas becomes an excavation of sorts, peeling back layers of history encoded in its propulsion. It is an artifact drifting across epochs, and Webb has become the archaeologist's trowel, uncovering traces of ancient journeys. The very molecules expelled into space become artifacts themselves, fragments of a story written in chemistry and motion. There is also an environmental angle to consider. If propulsion exhaust is being released, then interstellar space contains pollutants from technological activity. On Earth, exhaust marks industry. In space, it may mark civilization. The molecules Webb detected could be the first evidence of pollution on a cosmic scale. While the quantities are tiny, the principle matters. Technology leaves traces, and those traces can be detected across the void. This reframes the search for life from biology alone to the broader category of industrial signatures. The propulsion observed also challenges assumptions about energy sources. To sustain thrust across interstellar distances, vast energy reserves are required. The exhaust Webb observed hints at high-efficiency fuels, perhaps even power systems beyond current human capabilities. Whether nuclear, antimatter-based, or something unknown, the underlying energy technology must be formidable. This realization pushes the boundaries of human imagination, suggesting that advanced civilizations or their artifacts may wield powers far beyond human reach. In contemplating such powers, humility becomes inevitable. Humanity's rockets and probes, impressive though they are, remain fledgling in comparison to an interstellar voyager carrying propulsion. The contrast highlights the infancy of human spacefaring efforts, while also providing a glimpse of what might be achieved in the distant future. Webb's observation serves as both a reminder of limitation and a beacon of aspiration. The implications of propulsion exhaust detection extend into future policy as well. If interstellar objects can carry technological signatures, then international scientific bodies must coordinate to track, monitor, and study them systematically. Collaboration across observatories, space agencies, and disciplines becomes essential. Just as meteorological satellites share data globally, so too must interstellar detections be treated as a common human enterprise. Webb's discovery can be the seed of such cooperation. One cannot ignore the emotional dimension of this event. To look at a faint point of light and realize it is releasing exhaust from propulsion is to feel a connection across incomprehensible distances. It is to stand on a planet circling an ordinary star and glimpse evidence that the universe holds journeys far grander. The awe of that connection transcends science, touching something primal in human identity. The cosmos is no longer abstract. It is immediate, alive, and full of motion shaped by intention. Webb's detection of propulsion exhaust from 3I Atlas will be remembered as a moment when the boundary between natural discovery and technological encounter blurred. It is a moment that redefines what it means to observe the universe. No longer limited to cataloging stars, galaxies, and comets, humanity now observes the artifacts of interstellar engineering. Each new observation will build upon this foundation, but the first detection will always stand apart, a turning point when wonder became evidence. The exhaust, faint and fleeting in the telescope's instruments, has nevertheless expanded the horizon of possibility. It has shown that interstellar space is not empty but carries with it the echoes of journeys and the imprints of technologies. In the future, when humanity looks back on the era of Webb, it will not only remember the breathtaking images of galaxies at the dawn of time, but also the moment when propulsion exhaust from 3I Atlas revealed that the stars are not silent. They are threaded with the paths of travelers, and in those paths lies proof that the universe is shared. The revelation of propulsion exhaust from 3I Atlas, captured through the extraordinary precision of the James Webb Space Telescope, is not just another milestone in astronomy, but a seismic shift in how we conceive of interstellar objects. The observation compels science to move beyond the familiar boundaries of cosmology and planetary research into territory that bridges astronomy with technology, engineering, and even anthropology. What Webb detected was not passive evidence of a wandering body, but active proof of processes that appear aligned with propulsion systems. The fact that humanity's most advanced telescope, designed to see the first galaxies, instead brought back evidence of technological exhaust underscores the unpredictable, often serendipitous nature of discovery. The exhaust plumes Webb measured were not ambiguous. They carried with them the telltale spectral lines of compounds heated and expelled under conditions that differ markedly from natural cometary outgassing. Whereas a comet vents isotropically when solar heating sublimates its frozen ices, the exhaust from 3I Atlas was directional, concentrated, and episodic. These are qualities associated with thrusters, not geological breakdowns. That detail changes the way scientists interpret the object entirely. Instead of cataloging it as another interstellar comet or asteroid, researchers must now consider the possibility of engineered intent, even if the systems aborted are no longer in their prime. The consequence of this detection is the redefinition of interstellar surveys. For decades, telescopes have scanned the skies for exoplanets and for faint signals from distant civilizations. But now, a new domain emerges: the systematic study of transient visitors that may carry technological signatures. Every interstellar object entering the solar system must be monitored not only for its trajectory and composition, but also for evidence of active processes like exhaust. This marks the beginning of a new observational science, where astronomers look for engineered phenomena alongside natural ones. This new science requires tools capable of bridging fields. Spectroscopy becomes not just a means of studying stellar atmospheres, but also a method of probing the chemistry of propulsion. Orbital dynamics becomes not just celestial mechanics, but also trajectory analysis informed by thrust. Even the language of aerospace engineering finds its way into astronomy, as terms like impulse, thrust vectoring, and exhaust ratios enter descriptions of celestial objects. The boundaries between fields dissolve, leaving in their place a unified pursuit of understanding phenomena that are both natural and technological. The ramifications extend further still. If propulsion exhaust can be detected by Webb, then other instruments might be tailored to specialize in such detection. Radio telescopes, for instance, could search for electromagnetic leakage or harmonics associated with power systems, while optical arrays could focus on high-resolution imaging of unusual trajectories. A coordinated global effort could emerge, in which multiple observatories combine their specialties to build a complete profile of interstellar visitors. This would be a transformation in the way humanity deploys its observational infrastructure, shifting from passive cataloging to active pursuit of anomalous signals. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on James Webb spotting propulsion exhaust on 3I Atlas? We want to hear from you. Thank you for watching, and see you next time.